Hello everyone, you're welcome back to class. My name is Victor Odigoma here, and we are still looking at problems that are in line with indices. Problems that are in line with indices. Okay, you remember sometime in the past when we had geometric sequence and series, and from that sequence and series class, we had a geometric progression, and when we were looking at geometric progression, we came to, you know, sum of a geometric progression. You know, I came across this question. Right now, we are looking at indices, and I saw a connection between this question and indices. Where we're heading now is indical equations, equations that result has indices in them. Okay, so now I have to bring up this question so that we can look at it together. Now, if you look at this problem, please remember this is the 7th or the 8th class we are looking at in the indices. Okay, so that why I say so is that you can check out those classes. They are in this list. Okay, so that you look at those classes so that you can be able to meet up where we are. How can one be able to handle this problem that says how many terms of the sequence? The sequence is 3 minus 6, 12 minus 24. How many? We have the first 1, 2, 3, 4. How many do we need extra? So that when we take the sum, it will give us 1 minus 2 raised to the power 8. How many terms do we need to achieve that? How do we go about this? Now, when we were looking at geometric progression, we looked at the nth term of a geometric progression, and we came down to the sum of a geometric progression. Now, we gave two formulas that are used in calculating the sum of a geometric progression. We gave an instance where the common ratio is greater than 1, and another instance where the common ratio is less than 1. In that case, where the common ratio is less than 1, because if you observe this sequence now, you realize that here, like as we said in a geometric progression, that un is equals to ar raised by n minus 1, where here a is the first term, and r is the common ratio in that sequence. Okay, remember the common ratio. Anyway, all these things we discussed this in the class for geometric progression, so you can still check out those classes as well. So what am I saying here? Our a now is 3, first term 3, and the common ratio r is later divided by former, which is minus 6 over 3, and that will give us minus 2. You still compare it here, we still give you the same value. Now, you realize here that common ratio minus 2 is less than 1. And that is what is going to compel us to use this formula for sum of a geometric progression, which says, sorry, not sum to infinity. This is sum to infinity. So, sum to a particular nth term, okay, equals to a in bracket 1 minus r raised by n all over 1 minus r. This is the formula for calculating the sum of a geometric progression when the common ratio is less than 1. I hope I'm not too fast about that. So if we come here, this is the sum they gave of a particular nth term, which we don't know how many terms that are there. Then obviously we are looking for the value of n. So you can now make a substitution inside this place and say 1 minus 2 raised to the power 8. The sum of those terms equals to, first term is 3 in bracket 1 minus 2, because the common ratio we have is minus 2. We cover it and raise it to the power n, then cover this bracket all over 1 minus in bracket minus 2, because this r is, look at it here, common ratio is minus 2. You put it here, minus 2. You also put it here, minus 2 raised to the power n. You can see 1 minus r raised to power n. So this formula is something you just need to memorize. Okay, one just need to memorize it. Please, I did elaborate explanation of these things in our classes on geometric progression. I brought out this question because it has a link, a connection with indical equations, equations that has to do with indices, which we are looking at. And I'm sure that is going to help us to make more, get more understanding in what we are talking about. Okay, let's make a simplification of this problem. We have 1 minus 2 raised to power 8 equals to, then we have 3, and that 3 is in bracket 1 minus 2 minus 2 here, minus 2 raised to power n all over 3. Where is this one coming from? You can see it here. 1 minus in bracket minus 2. That will give you 1 plus 2, which is 3. Okay, from here. Okay, so let's make this over 1. Even if we didn't make it over 1, this can take away this. I'm sure you can see that. So we can now bring down 1 minus 2 raised to power 8 equals to here 1 minus in bracket minus 2 raised to power n. All right. So what again? We can remove 1 from both sides so that this will go. So take away 1 from both sides. You can now have minus 2 to the power 8 left equals to, here will be minus into minus 2 raised to power n. If you look here again, you realize that if I divide both sides by minus 1 so that this negativity can go, so here will be minus 1, here will be minus 1, so that I can take away this and take away this, and I will have 2 raised to power 8 left equals to minus 2 raised to power n. Raised to power n. So at this point, indices comes in. Indices comes in because if you have something like 4 raised to power n equals to equals to 16 equals to 16. Simple thing I have to do now is to write 4 raised to power n equals to, this is 4 raised to power 2, and since the base are equal, it then means n is 2. That's how indices comes in. So if you have a problem like this and you have 2 raised to power 8 equals to minus 2 raised to power n, how can you be able to apply this knowledge and come here to able to make a logical conclusion out of this? You get? So what we have now and what we are going to have as our conclusion is that just put n to be 8. You get? If you put n here now to be 8, because are you aware that any negative number raised to power even becomes positive automatically? That is, if I have minus 2 raised to power 4, this is 16, and it is the same thing as 2 raised to power 4, which is still 16. So if you accept this, it then means n is 8. Without too much explanation, n is equals to 8. If you understand this explanation I gave here and this explanation I gave here, that any negative number raised to power even is positive. So that means n is 8. Reason, since if you put n to be 8 here, that this 2 raised to power 8 will be of the same value as minus 2 raised to power 8. So that's a conclusion. I'm sure that this intermarry between geometric progression and indices is well explained and very, very clear to us, so that we can be able to open our mind to be able to reason any place such application is required. Thank you so much for being there. Please share this video to your friends out there, and like our video and click the subscription button to promote us in what we are doing. And then what again? Click also the notification button so that you'll be notified. Please take note, I have told you before, but I'm saying it again, that we have done several classes in indices. We're almost coming to the concluding aspect of it. What I do is I pick a topic, discuss it in detail before I now start solving problems, so that no, you don't just look at a problem, you come from the point of understanding of that topic, so that the target is you to be able to apply the knowledge you've acquired to solve other problems out there when I will not be there. So thank you for being there.